All right. I am going to go over these three problems from the formative to kind of recap where we were before break and try to refresh some of those ideas. The first one is asking us to find the area of a regular hexagon that has the radius of 8. The important thing to remember from what we were doing in class 2 weeks ago, a little over 2 weeks ago, was that we want to turn it into a triangle. We want to find that central angle, use the apothem, that line that goes from that center down to a side length, use the apothem to cut it in half, which cuts the central angle in half, and then we're going to use trigonometry. And so let's do it. All right. The first thing, let's turn this into a triangle. Like this. All right. So we have a triangle. The first thing we want to do is find that central angle, this angle right here. To find that central angle, what we have to do is 360 divided by the number of sides, and since this is a hexagon, it's got 6 sides. All right, so 360 divided by 6 gives me a central angle of 60. But then we drop this apothem down, and that's terrible, but that's the price I pay for working on my computer. You drop that apothem down, which cuts your central angle in half so that this half is just 30. All right, so if I redraw the triangle, the one that I should really highlight it, I have, this is 8, this angle right here is 30. I have to find what x is, and I have to find y, because I need the base, I need this base down here, and I need that height to be able to find the area of that one triangle, and then we multiply the area of one triangle by the number of sides in the shape. All right, so let's focus on this right here though, this triangle right here, so we can find x and we can find y. This is where the trigonometry comes in. We have a right triangle because the apothem formed a right triangle. And so we have to use trigonometry to solve for x and for y. Well, if 30 is my angle, x is the opposite side, and 8 is the hypotenuse. X is opposite because it's across from the 30, and 8 is the hypotenuse because it's across from the 90. Okay, so this is a sine problem because this is opposite hypotenuse. And so to start finding x, you have to use the sine of 30 equals your opposite, which in this case is x, over your hypotenuse, which in this case is 8. Okay, and we've done a lot of these in class before. I put the sine of 30 over 1, and I cross multiply and solve. All right, 1 times x equals x, and the sine of 30 times 8, let's see what that is on my calculator. Sine of 30 times 8 is equal to 4. All right, and so we have x now equals 4, which means my entire base, this little piece here is 4, but the entire base is 8. All right, the x to find our base. Now we're going to need to solve for y to find our height. Okay, so I'm going to work below the circle here. That last one I used the sine of 30 because it was opposite in hypotenuse, the x being opposite and the 8 being hypotenuse. Now I'm going to use cosine. I'm going to use cosine here because y is my adjacent. Y is between my angle and my 90, and 8 is still my hypotenuse. And so if I'm using adjacent hypotenuse, it's a cosine problem. And so then I use the cosine of 30 equals my adjacent, which is y, over my hypotenuse, which is 8. Okay. Now I again do cosine of 30 over 1, so I can cross multiply here and solve. 1 times y equals y, and the cosine of 30 times 8, let me bring up my calculator again. The cosine of 30 times 8 gives me 6.93 if I round it. All right, So now I have my y and I have my x. And if I look over at my left shape here, I have a base and now I have a height that is 6.93. And remember, the area of a triangle is just 1/2 base times height. So I have everything I need to find the area of that one triangle. And let's do it. Okay, so if I want to find the area of just that one triangle, it is 1/2 times the base, which is 8, times the height, which is 6.93. Okay, 1/2 times 8 is 4. 4 times 6.93 gives me an area of that is 27.72. But that's just the one triangle. Okay, that's just one triangle. That hexagon is made up of 6 triangles because it has 6 sides. And so we have to just multiply this 27.72. We got to multiply that by 6 to account for all the triangles. And that leaves me with a final area of 166.32. And I don't have any units on here, but 166.32 units squared because it's an area. And that would be my answer. All right. So hopefully when you did this and turned it in, that's what you got as an answer. If not, that's all right. Make sure you're watching this video and you're trying to understand and emailing me any questions about this. I can always work another problem and show you if you want to see another one. Let's move on to number 2 here though. Okay. It's saying if figure A has an area of 45, so this area in here is 45, what is the area of figure B? And so this is actually a question using just linear scale factor and area scale factor. Okay. And so linear scale factor, this is again, 2.5 weeks ago, but linear scale factor is what we saw sides get scaled by and perimeters get scaled by. All right. And so if this side length is going from 5 to 25, if it's going from 5 to 25, that is a linear scale factor of 5 because the multiplier needs to be 5. 5 times 5 gives me 25. So the linear scale factor, I want to erase that. The linear scale factor is equal to 5 because that's the growth of our sides. Well, the other thing that we talked about on like 2 weeks ago, I should say, not on the day, but like 2 weeks ago, was that if we know the linear scale factor, we can find the area scale factor. If we know linear, even if we know area, it goes both ways, but if we know linear, we can find area scale factor because area scale factor is just the linear scale factor squared. So in this case, it is 5 squared, which tells me that my area scale factor is actually 25. So even though my sides and my perimeter are growing by a multiplier of 5, my area is growing by a multiplier of 25. Okay, so if my starting area is 45, to get to my new area in here, I'm going to have to multiply by 25 because my area scale factor is 25. All right, so this problem is actually almost done already. To find my answer, I have to take my original area, which is 45, multiply it by my area scale factor, which is 25. And I just got to use my calculator. 45 times 25 gives me an answer of 1,125. And since I'm working with inches, it's still in inches squared, because if it's an area, which it is, it's always your units squared. All right, so your answer here, 1,125 inches squared. Just remembering, this is a good problem to remember what it means to be a linear scale factor. Linear scale factor is the multiplier that grows your sides or grows your perimeters. And area scale factor is always that linear scale factor squared. Sometimes you're going to be given an area scale factor and asked to find the linear scale factor. Well, that would be the square root then. So say like, yeah, I know the area scale factor is 25. Well, what's the linear scale factor? Well, it's the square root of 25, which would be 5. Just important things to remember, because in our unit, or our lesson, I should say, tomorrow, I use some of that vocab. All right, last one, I believe, right? Yeah. All right. If the shape below is enlarged to a new area of 400 centimeters, what is the new perimeter? Okay. So we have an area, it's saying right down here, the area of this shape is 100 centimeters. All right. And there's a new area, same shape but just enlarged. The new area would be 400 centimeters squared. All right. Well, that is a growth. From 100 to 400 is a growth multiplier of 4. All right. And since this is areas, since these are areas growing, this is telling me that my area scale factor must be 4. Because the multiplier from one area to another is 4. So this is like I was just talking about. This is one where they're going to give you an area scale factor. You need to find a linear scale factor. All right. So if my area scale factor is 4, my linear scale factor is the square root of 4, which is equal to 2. My linear scale factor is 2. Now, I need that linear scale factor because I know that side lengths are scaled by a linear scale factor and perimeters are scaled by a linear scale factor. So what I can do is I can find the perimeter of my original shape here, my smaller shape, and multiply it by my linear scale factor to find the perimeter of my new shape. And so that's what we're going to do here. All right. So to first find the perimeter of this shape, what I need to do is add up all the side lengths because that's how I find perimeter, which is 8 plus 4 plus 5. Oop, that's an 8. 8 plus 4 plus 5 plus 10 plus 13 plus 4. And I think that's everything. And so my original perimeter is going to be, and I want to use my calculator too, 8 plus 4 plus 5 plus 10 plus 13 plus 4 is 44. My original perimeter is 44. Okay? Well, perimeter grows with the linear scale factor. And so if I want to find my new perimeter of my new bigger shape, I need to take 44, multiply it by my linear scale factor, which is 2, which gives me a new perimeter of 88. Do I have units on here? Centimeters? Which is 88 just centimeters. And it's just centimeters, not centimeters squared, because this is a perimeter and not an area. All right? But this is an example of a problem where you're kind of working backwards from what we did in problem 2. You had to find your area scale factor first. And again, I found my area scale factor because I knew that one of my areas was 100 and my new area was 400, 4 times bigger. All right, and so my area scale factor is 4. I was able then to find my linear scale factor because my linear scale factor is the square root of my area scale factor. That gave me 2. Then I found the perimeter of my original shape, multiplied it by 2 to enlarge it to my new shape, and that gave me 88 centimeters. All right. All this is a good recap, especially going into our lesson tomorrow. Hopefully you gave this one a try and turned it in before you watched the video. Either way though, even if you just watched the video, it's a good recap. So thank you for the time, and hopefully this helps going forward.